Greetings. This is Linda Kilenaibale together with Khadija Akman, and we're going to take you through the MLOPS of the research, which is quantum feature extraction and learning for brain imagery with knowledge distillation. We're going to be looking at the mode of deployment that we used, the different deployment strategies we used, the different monitoring and version control systems we used, the challenges we faced, and the best practices we learned. Then we'll be demoing our API. These are the steps we followed in the MLOPS deployment we did. So first, we saved our model as a serialized format using TouchScript for efficient loading. Then we deployed our model using Flask as a REST API. Then after that, the API was able to process image inputs to run inferences and return predictions in real time. And this will be illustrated in the model, in the demo. Yes. So Khadija can take us through the MLOPS deployment strategy. Thank you.
Thank you so much, Linda. So here is our MLOPS deployment strategy. So initially, in the pipeline, we start with the model development and training, then optimization. And this is where we get to analyze all the models we built and then pick out the best performing models. So when we have the best performing models, we save it and then we serialize it in form of like a touch using TouchScript in the PTH path, and that will be the format that we use for deployment using the Flask API. Then, of course, we're using Flask for the API development. And then for the containerization, we chose to use Docker. Yeah, and then for the cloud deployment, we will probably use what's its name? We had it this morning. It's called Cloud. Sorry about that. Yeah, so we will try other platforms like Azure, AWS, and then also the free open source platforms for deployment. And then for the version control, we have GitHub, which automates the testing, building, and deployment updates to the cloud. And then we plan to have to integrate our model into MLflow, sorry. And this will help us log the model versions, hyperparameters, and also to be able to track the model performance metrics. And then, of course, we'll have real-time monitoring to check if the model has any errors or the performance has deteriorated. This is just a diagram showing the basic MLflow pipeline, where we start with the data, extraction and analysis, then you prepare the data, build the models, train the models, evaluate the models. Then we have the trained models that we serialize and then we serve using the Flask API, and then the consumer or the user uses it to get predictions. So the best challenges and best practices. One is scaling. For purposes of scaling, it's very important that even when we have high traffic in the application, we need to be able to scale and handle. So for that, it's best to use, we shall use Kubernetes to help us with the scaling, automatic scaling. And then we can also have, we can also integrate things like, in case of storage, we shall integrate things like AWS, the auto scaling to help us with the scaling. Then we have model updates. It's important to implement canary deployment to test new models on just a subset of users before rolling out. And this just helps to minimize the risks that are associated with updates, such as downtime when like things are happening and then people cannot use the application, or when errors go down and then everyone else cannot use the applications. Then we need to be able to handle errors. And to do this, for example, in our application, we have implemented like a small functionality such that when the model is making predictions, we show the confidence level so that the user knows like how confident the model is. And then it's also good to have feedback mechanisms to handle these errors and be able to, fallback mechanisms to handle these errors so that we can always go back and check on what is happening with the model and then retrain. Then security is another thing. For example, in the health domain, security is very important because, for example, this application, this model is going to be dealing with image data that is related to patients, and this is more like patient personal data. So authentication is very crucial, and this needs to be added to ensure that only the authorized personnel can access it. Then data integrity and compliance, we need to also do regular audits to make sure that we are complying with all the regulatory authorities and that the data is actually safe. Then automated testing, continuous testing using unit tests, then integration of the test and loading tests ensure the system reliability before deployment. Yeah, so now moving on to the demo. I hope we can be very quick with this. So we'll start out with our, just to highlight, we developed a CNN model that is just a CNN model alone without knowledge distillation and without the the quantum model. And this quantum model actually performed really well. Like its performance is really, really good when it's just like a single quantum CNN model, which I'll see its performance because we tried to deploy it and its performance is really good. So here is our Flask application that is for the CNN model with VAT and knowledge distillation. So here, the normal Flask thing, we started by bringing in the model architecture because this is what we need to be able to load the image and then also evaluate it. So we have this is just a name. It's supposed to be a CNN. As you can see, there is no quantum anything. It's just a name. We have the CNN part of the model, and then we have the vision transformer part of the model. Then a combination of the two, which is the CNN that starts first with the initial feature extraction, and then we pass them on to the vision transformer, and then we have a fully connected layer that does the classification, and that is our student model. Then we have the base model that was saved under this file name, and then it's saved in the same folder as the Flask application. So we bring it in so that we can get weights from it and be able to do the predictions. So here we're loading StateDict, which brings in basically just gets us the weights from the saved model so that we can use them to make the prediction. And then we are setting the model to evaluation mode. Then we also need to be able to transform these images because they can come in any size. But then our model uses 150 by 150, and this is what we want. We always resize the images to 150 by 150 to ensure compatibility. Then I can take on from here.
Okay, so after that, we need to we use the HTTP methods, the get and post, for which the get will be getting the images from the user or from the front end as they will be posted. And then the post method will be used to show information. The get will be getting information from the front, and then post will be getting information from the back. So we had to put we had to validate this such that we check whether the file has been uploaded or yet. If it's not yet, we will give an error message that no file is uploaded. Then when the image is uploaded, it's put in an image path, in a folder called images, put in an image path. Then it is saved. Then after that, it is opened, put in an image. Then the image is transformed. After it being transformed, Then we pass it into our model without any gradients because we're not checking anything. Then we are checking it against an array which contains the glioma, meningioma, normal, and pituitary names such that we check them by the class ID. This array contains the class ID of which this is 0, 1, 2, and 3 by those positions. So given the image that we get, if the class ID is 1, then they will tell us that the prediction is glioma. They will instead return the value of that particular index. Then we return the confidence level as a percentage. As you can see, we convert to percentage. Then we render it on the index on the HTML as a prediction and the confidence level. Then we call the main method. Yes, please you can now show the font, like the illustration on the built API. Yes.
Okay. So this is the model, the CNN and VAT with knowledge distillation. And basically what we have to do is upload an image and then click on predict, and it gives us the prediction and its confidence level. So to randomly pick, let's say glioma. When I click on predict, this should be able to give us the prediction that it's a glioma and it is 92% confident. And this is true because I uploaded a glioma image. Then we can try out another one, let's say meningioma. Randomly, let's say this one. This is meningioma. When we click on predict, it should be able to give us the prediction and then its confidence level. And this one is fairly okay. Let's try another class, the normal class. Yeah, this is also 82% confident and it is normal and it is for real. We uploaded the normal image. Then the final class, which is pituitary. Yeah, this is it's quite confident about the predictions, and as you can see, all of them are at least above 70%, which shows that the model is fairly okay. Then I would like to take you through also the quantum CNN model that we developed, like just quantum CNN without any knowledge distillation or any without knowledge distillation, sorry. Because this model had accuracies of about 90%. And when you deployed it, it actually shows that the predictions are really, really good. So when I select, let's say, randomly, meningioma, I have 97% accuracy that it is meningioma, and it's truly, I uploaded a meningioma image, and that is actually good. Then we can try, let me just select the same one I selected for the previous one, normal. It's 99% sure, confident that this is normal, and this is really good. Then we can try out pituitary, like the one I selected earlier. That was this. You can see that it is really, like the confidence levels are really high. So this model, this quantum model actually performs really well. Yeah. Then we also have the models were Dockerized, but then we haven't yet gone on to like the actual deployment or actual Dockerization because we had some issues, but this is going to be the next step from that. Thank you.
Okay, thank you so much.